Hello everyone, my name is Prasant and I am TIDSP Lab RA. This is Lab 7 of course EE352. We have divided this lab into two video parts. First part contain concept of direct memory access DMA, its architecture on TMS320c5515, and second module contain about implementation in C. So let's begin. Before we start discussing about DMA, let us think of an application in which we want to do signal spectrum analysis. And our specifications are we will do 1024.DFT using FFT algorithm. Our input sampling rate is 48 kilohertz, which means that after every 20.8 microsecond a new sample is coming. And in the process we will be using an FFT hardware accelerator coprocessor which take about 219 microsecond for doing 124.FFT. So on the basis of this timing analysis specification we can conclude that while doing FFT we would definitely miss some input sample. So in this application if we use DMA, then this issue of losing the input sample will be gone. This shows about the conceptual diagram of connection between DMA controller and parts of DSP, which mean that peripherals like codec can be directly accessed by CPU or via DMA. This is basic architecture of DMA. So DMA communicate with peripheral device like codec. It will take input data sample and put this sample into a memory location. This memory location is read by processor. Processor will process the input data sample and will put the output data sample in some other memory location. And in this memory location is accessible by DMA. It will read DMA will read the input sample output sample data and will put on codec. This is the flow diagram that how DMA work. Now one key concept is coming. This input memory, about this input memory. This input buffer memory is divided into two parts. First part is called ping and second part is called pong. After understanding the basic functioning of DMA, now we will see how processor get extra amount of time if DMA is used. Our input buffer is divided into this two part, ping buffer 1 and pong buffer 1, and DMA is continuously taking data from codec. In our application we have to do this 1024.FFT continuously. Let's suppose this the very first 1020 point was stored in this pong buffer 1 by DMA, and now the second chunk of 1024 is being stored in this ping buffer. That will take about this 21 millisecond amount of time. So the CPU have about this 21 millisecond amount of time to process this first block which is stored in this pong buffer, and after processing can paste in this pong buffer 2, and after this 1021 to 21 millisecond DMA will switch back to this pong buffer. So the third block of data is now getting stored in this pong buffer, and now CPU will read data from ping buffer. So this is how by alternatingly changing the storage buffer from ping to pong to ping by DMA, CPU get an extra amount of time and there is no problem of missing the input sample. Similarly at the output buffer also the DMA is reading data from ping and pong alternatively. So till now we have understand DMA functioning and how this ping and pong are useful. This is a part of next video module. in which we will see that how this DMA is implemented on TMS320c5515 या 35 DSP kit.